morning. My name is Kishore Esanakula. I'm a healthcare solutions architect. And if you missed yesterday's session or the previous ones, I would recommend that you go through the videos, the recordings. And if you wanted to know a little bit about me, I am one of you. I went through Vidyaniketan just like you're going through right now. You know, bicycle to the bus stop and took bus to the college and back for 4 years. You will get the slide deck and you will get to read a little more about me. And all right, so for the sake of those that have not attended yesterday's session, I want to quickly recap what we learned yesterday. We've created a fictitious organization with an idea and a solution, and we saw how the organization grew into a profitable organization in 3 years, and we saw how it got out of control after that. And we figured out that something had to change, something had to happen for the organization to scale and to be agile as it was at the beginning when it was a startup. Now, there was a video that I shared with you yesterday. Let's quickly go through that. It's not very long and it's short, and it gives a very good overview of what we covered yesterday. If you have your headphones, please keep the volume at an optimal level. All right, great. That was very informative. And I'm not going to get into the definitions of enterprise architecture and such, but I do want to remind you that organizations, um, enterprise architecture helps you understand how, what an organization does, how the data is flowing, how the applications are architected, and it also helps the fundamentals. Basically, it helps you understand people, process, and technology within an organization. Now, other benefits, please read through those. I don't want to get into the details. Please listen to the recording from yesterday. We also looked at a business architecture value stream, and this value stream ties you back to the healthcare capabilities and clinical decision support systems using AI and ML. So that session ties this diagram back to the value streams. All right, so we have about four other pieces of enterprise architecture that I want to cover with you today. Integration architecture is so if an organization has a bunch of applications, and if you're trying to understand how the different applications are integrated with each other, how the data is flowing between each other, what kind of protocols are used, what kind of cadence, like are they integrated using web services, making real-time calls, or are they exchanging data using ETL jobs, and et cetera, et cetera. I want to show a few diagrams in here that would be nice to look at. Some example integration architecture diagram. This is an example integration architecture diagram. And let's walk through this as if you and I have no clue what it's doing. So I always believe in starting with the end user. Apparently, there's a client here, client, end user, right? What it's showing here, these two lines, is that this client is authenticated using Azure Active Directory. So this client's identity is stored in Azure, and we're leveraging Azure Active Directory to authenticate the client. Then there is a API management capability that leverages an API gateway to send the calls back and forth between the client application and the Logic Apps workflow and orchestration engine, which is in Azure. This box right here tells you, gives it away that it's an Azure thing. These workflows and orchestration engines apparently call other services in the backend. It's showing that it actually calls other software as a service services that are probably hosted in the cloud somewhere. And it also says that it calls them Azure services, this arrow right here. And down below, if you look at this, what I see here is that this workflow and orchestration engine, the orchestrations and workflows that are deployed in this Logic Apps also publish messages to a service bus. This is an Azure service bus. So messages are published. And you also see that there is an event grid within the queues and events. Apparently this orchestration that's deployed in the orchestration engine also subscribes to events happening within these Azure services. So in the Azure services, there are events happening. And in the service bus, there's a message-based services up here, and they are publishing messages to the service bus. As service bus is processing messages, it is also publishing events that are subscribed by the Logic Apps. I've used two terms that are very critical for you to understand when it comes to integrations: publish and subscribe. You publish to a queue, and you can subscribe from a queue. Within the messaging architecture, there are queues and topics. In this case, we are talking about queues. Queues, as you may have learned in data types and data, I'm losing the term here, but you probably learned during your data types classes that queues is first in, first out. Topics is multicast. So if a message is published to a topic, whoever is subscribing to the topic will get a copy. So it's one to many. Queues is one to one. Now, let's see, what else are we seeing here? So at the bottom, apparently, this API gateway has some web services that are REST and some web services that are SOAP that this API gateway would call. So what it's telling me is that this application that I'm looking at runs in the cloud in Azure, and it calls some cloud-based services, some Azure services, and it also calls some services that are not based out of Azure. And these REST and SOAP, these are more than likely at the bottom right corner. These are more than likely deployed on premises somewhere. Don't be don't be under the belief that they're not using HTTPS. HTTP and HTTPS are used synonymously, and more than likely there is security behind all of these communications. So this is a good example of an integration diagram. So let's go back to another example here. This is another type of integration diagram, and I like this. One of the benefits of this diagram, or the one thing that I like about this diagram, is that there is 1, 2, 3, 4. There is a sequence of events that are happening, and they're labeled. In the diagram before this, they were not labeled, and we were using our knowledge and experience to figure out what was going on. However, in this particular diagram, we're able to see that it's labeled. And as you can see, it's more legible. It's more easy to read. So let's start with number 1. There is an online store. I see an online store. There's a person holding what looks like a laptop or a tablet. And there's a web-based application. There's a web application that's publishing messages to a service bus queue. And number 2, apparently these messages are being sent to a Microsoft BizTalk server. It's a 2013 R2. If you want to know more about Microsoft BizTalk server, please do search and read about the Microsoft BizTalk server. It's a very robust integration server. It comes into the same category as TIBCO, Pega, a few other products. MuleSoft is one of the big ones. As a matter of fact, I started off my career being a Microsoft BizTalk developer. I would say mid-career. I started off my career as a C#.NET and Java developer, but do look into BizTalk server. It's a great suite of functionality, great product. Then we see that number 3, there is some file system. Apparently this BizTalk server is writing some files to a folder, is what I see at number 3. Number 4, it looks like it's actually calling some sort of an endpoint that runs a logic app within Azure that interacts with the CRM. Probably too much for this conversation, but remember that CRM, you can Google for it. It's basically customer relationship management suite. There's a bunch of applications out there. Salesforce is one of the big players in that. And after number 5, apparently this orchestration that's deployed in the Microsoft BizTalk server is what looks like somebody is looking at some key performance indicators to see how this particular business process that is deployed in Microsoft BizTalk server is performing. Somebody is looking at key performance metrics. So this process that's deployed in here is being monitored by this person up top in here, very KPIs. And apparently this Microsoft BizTalk server process actually sends what looks like emails or messages to this individual who is sitting at this desk. So this is a typical integration diagram, and I would say this is more a contextual integration diagram because there is more information about context. There is end users, there is systems, right? And there's lines connecting different systems, and there's directions on those lines, and there is 1, 2, 3, 4 sequence. So this is one of the more better ways to document an integration diagram. So the most important key thing to have in a diagram for an integration diagram is the end users, the systems, the directional lines and the directional lines being labeled. You have to have labels on them, and it should be complete in its existence. For example, in this case, if you just had the end users and you finished it as a developer, which is a typical tendency, then somebody who's interested in KPIs, key performance indicators, they may not be too happy. Usually, the people who are interested in KPIs, your leaders of the organization, could be a vice president, could be a CEO. So it's important to make sure that your process that's deployed in an integration suite like Microsoft Desktop Server is measurable, that somebody who cares about this process has the ability to measure it. All right, let's look at a third example. This is another way of diagramming integration diagrams. And I would put this into more a integration diagram that's more conceptual in nature. It is flowing from left to right. There's nothing wrong with this diagram. It's basically showing your layered architecture, layered hierarchy, the different views for different purposes, right? This might be a diagram that is appealing to certain part of the organization that you're trying to communicate, right? When you create a design diagram, your intent is to communicate your design with the rest of the organization, that you're expecting some sort of a function to happen within your product, within your application. So there is an end user. There's currently a store front end, and we're saying that the store front end web application calls go through an API gateway, and we're saying there's these services that are deployed. Apparently, this is a payment service, is a stateless Lambda, right? The symbol stands for your Lambda in AWS, right? And then you have your DynamoDB, which is a NoSQL database, and you have your relation database. So these icons in here, what I want you to remember is that using different type of icons in a diagram will convey meaning as well, in addition to the different types of diagrams that we've seen, using appropriate icons. If you are an organization that uses AWS, then this diagram would be very nice to them. They would immediately know that this is a Lambda-based, meaning serverless compute, serverless processing on AWS, and this is a DynamoDB. These are standard icons. So when it comes to enterprise architecture, we'll talk about in a couple of minutes, but what is key is that the consistency, to make sure that the diagram created by different individuals in an organization be consistent. If they're not consistent, the audience will have a hard time understanding what the application is doing. So keeping them consistent means you have to have standard icons. Standard icons, if you're using Visio, then standard icons come from the Visio stencils. You can actually create custom stencils as well. And custom stencils can be shared across teams as a common shared library. You can put that on SharePoint, version control it. There's several different ways of version controlling a stencil. Well, I just used the term version control. It's not part of this topic, but it's actually a key functionality or key consideration or something that enterprise architecture cares about, is to make sure that the organization has a good version control system to manage your code versions. For example, you could be using GitHub, you could be using Bitbucket, you could be using Team Foundation System, TFS or VSS. There is Subversion. There's all kinds of version control systems out there, both licensed and open source. One of the concerns of enterprise architecture is to make sure that the organization is actually using one of them. All right, that's integration architecture. Next, services catalog and SLA. So this is very key, and not many organizations have a matured set of services catalog and SLA. Let me talk briefly about what is services catalog and SLA. Let's say that you have an organization that, let's take the fictitious organization we built, the COVID organization, right? COVID model, and we have a API published in AWS, and that API is being consumed by several hospitals in the region. We said, let's say that SWIMS is consuming those services, and for SWIMS, we have published the API in 2 different environments. We provided them a test environment so that SIMs can do development in their development environment and call our test endpoint. And we also provided them a production environment where SIMS production systems would call to execute the model. So I just use two terms, production and test. Typically, for a given product or an application, especially APIs, you'll have to maintain at a bare minimum test and production. So some organizations might ask you to have a training environment that they can use with some dummy data so that they can train their end users, like they can train SWIMS nurses and doctors. So at a minimum, you have to have production, test or development in your case, and then training. Training is very critical. Now, you have these environments and you're going along your happy life and you know everything's great. All of a sudden, you have another hospital that came in and you have to make some changes to the service specifically for that particular hospital. So you're versioning your service, your model, and you're deploying another API. Again, it's COVID model. It might have additional parameters on the model. And you have to now spin up this API. You have to now provision a new set of EC2 containers, which is basically your virtual machines or computes. And you have to provision certain amount of block storage for this new API. Now, let's say that somebody in your organization is a AWS admin, and that AWS admin is performing the functions of provisioning EC2 containers and provisioning these block storage and such on AWS. A service catalog is basically those set of standard functions, right? This AWS admin all day, or he or she does, is provisioning AWS capabilities. They could be EC2 containers, DynamoDB, storage, S3, whatever the case might be, whatever the requirement might be, all day their function is to create those. And for your organization to have a predictable timeline on how long it takes for you to spin up another set of APIs for this new hospital, you need to understand how long it takes for each and every single step that's needed within that project. So some of the steps are predictable, meaning to spin up an EC2 container, maybe it takes 6 minutes, right? So you could have a service catalog that lists all of these activities. You can have, so API gateway setup takes 2 hours. So, spinning up an EC2 container with all the bells and whistles takes 1 hour. And you could set up this list of items that you usually use typically every day. And you can time box them and say, each of these take this much amount of time. And at the end of it, imagine, if you are from morning to evening human beings, we know how much time we need to brush. We know how to sit at the office desk. So service catalog is nothing but that. All the things that the organization does, right? Intricate things that need to come together and happen for the API to publish. And having an SLA, service level agreement, for each of those service items so that the end need, meaning publishing an API, the time that it takes to publish an API is predictable. Let's see. All right, security architecture. This is one of the most ignored. There's a whole lot of information published out there, and I want you to have the most amount of interest on this topic, because you will have your future secured quickly if you become a pro in security. If you're a geek as far as development goes, and you can pretty much develop on any platform, any language within 3 weeks, right? Oh, by the way, the key thing to remember, this is my philosophy, is that it's not very important for you to be master at 10 different languages, right? That's not important. What is important is that you can become a master at any language given a reasonable amount of time. Like if you're given 2 to 3 weeks, you could become a master at any language, any platform, any framework. So that's the key thing you should have. Your curiosity, your ability to learn concepts quickly is what defines you as an individual, as a resource as a leader if and when you're on business. Ability to learn and being curious about the right things is more important than your ability to memorize 10 different languages and all of their syntaxes and semantics and such. All right, so security architecture. What are the concerns of security architecture or a security architect? We have a list in here. There's a link down there. Please feel free to click on that and read through. But I'd like to touch on each of these so that you have an idea. Authentication is very important. Before you allow anybody to either consume your API or access an asset on your website, especially if it's a confidential asset, you want to make sure that you authenticate, make sure that it's actually for example, the API call SWIMS, in the SWIMS example, right? The COVID model. You want to make sure that it's actually SWIMS who's calling the COVID model. You don't want somebody else calling your COVID model. It wouldn't be very nice, right? They would basically be stealing at that point. So you need to make sure that you authenticate SWIMS using some sort of a mechanism that helps you understand that it's them, right? It could be multi-factored. You may have given them a username password, which is very old school. You may have given them a really long 256 character long key, in addition to a unique certificate to them that identifies them. And you may have put additional controls in place to uniquely identify them. You may have asked them, hey, SWIMS, when you make your API calls to us, what IP addresses are you going to be coming from? So you can actually put all of those controls into your API to make sure that you have the ultimate control on who is calling. So that's authentication. Authorization is once the authentication is complete and you have an identity established, what can they do, right? If let's say your organization has grown to the point where you implemented your COVID model, and in the same API, you implemented a SARS model, you implemented a MERS model, because these are all closely related as far as their genealogy and the virus genealogy goes. So you want to make sure that SWIMS is only given COVID access because that's the COVID model access, because that's the only model that they paid for. Their license only allows them to call the COVID model. So you have to have a robust authorization mechanism in place that after authentication, it validates that it allows them to only call the COVID model. Now, you might decide to make the descriptive information or details about these services publicly available. You can publish metadata about your API public, which is fine. But as far as calling the service goes, you have restrictions on who can call and who cannot call. So that's the difference between authentication and authorization. Audit, it's basically the ability to do forensics. If something was to happen on your API, somebody attacked it, somebody did a denial of service attack on your API, you need to make sure that you have enough information collected on your system to be able to analyze what just happened. Things that you want to know are where did the connection originate from? What IP did these calls come from? What authentication information did they use to get to the API? What authorization were they given to be able to get to the API? Did that particular organization that you gave the authentication information for, did that particular organization get compromised? How did this rogue end user of the API get the authentication information? So how did this somebody in in a not so nice part of the world get hold of your authentication information or SIMS authentication information? So you'll have to go through that audit and turn around and call SIMS right away and let them know that their credentials have been compromised, and you have to issue a new set of authentication credentials to SIMS and tell them that, hey, you have a new set of credentials, your previous credentials should no longer be used, and you take actions to mitigate that breach of insecurity. And so on and so forth. There's other parts in here that are less relevant to you, but just please do read through the hyperlink right below. All right, so let's see if there is anything that is worth let's see. Yeah, availability, asset protection, and they're pretty self-explanatory. So please do read through them. I'm trying to see if there's anything that is out of the ordinary. Oh, something that's missing in here. It's very important is privacy. So yeah, when SIMS calls makes the API calls to your COVID model, right? They must be sharing a certain amount of patient information within the code, within the calls, and you need to make sure that that patient information is kept confidential. So you need to maintain the privacy of the end user, the patients. You should not disclose that to anybody else. So you need to make sure that there's enough controls in place to capture who has access to that information in your DynamoDB or your RDS relational database in AWS. All right. Um, Facilities architecture. All right. So enterprise architecture deals with facilities architecture as well. This is probably one of the things that is very familiar with to you or in general. So facilities is basically your buildings, your desks, the way the cubes are laid out, the way that different amenities of an organization are, where are they kept, what kind of flooring is used, how much humidity is in the air, what kind of air conditioning system do we have to use, how efficient is the system, how do we make sure that the air conditioning system is not taking too much electricity, how well lit, where are the lights located, is it is it well lit, are the pathways wide enough for people to walk around, are there any obstacles, if the building is supposed to be a physically handicapped accessible certified building, then you need to make sure that the building has physical access as well as security access. For example, wherever you're supposed to scan or the names are labeled, you need to make sure that there is the labeling includes labeling for somebody who is unable to see and blind, and they can touch and feel the labels and able to figure out an ER room versus a primary care physician's office and such. Let's see. It also deals with where different things are kept. Where's the elevator? Make sure that there is a map, exit map. If you're in the building, you need to make sure that there's a map that helps you understand how to exit the building safely in the event of fire. And it also shows in the map where the fire extinguisher is located. Right, so there are all those aspects, along with in the event of inclement weather, the building that map will also include, hey, here's where you should go take shelter, which places are safe in the event of a tornado, what's the safest places in the building to be. And right below, it actually shows a parking lot with cars and bicycles and such. So it actually deals with quite a lot. So facilities architecture is something that's part of enterprise architecture. And not a whole lot of people realize this, but it is part of enterprise architecture. Let's see, there's a different, and I want you to read through this one. This is a very interesting article. As because of COVID, right? People like myself, I'm actually predominantly working from home. How am I impacted? And this article speaks about how different organizations that actually have people coming into the offices have to be accommodated to make sure that they're not impacted, or they're not exposed to the COVID virus. So this is an article that explains how different organizations are taking steps to keep their employees safe. Right? This talks about how to keep a hospital safe. So do read through this article. You will get the link when I distribute the slides. It's on the facilities architecture slide. Next one. Let's see here. Yeah, this actually shows the differences between the pre-COVID, how a hospital room used to be and where different things were kept. And now post-COVID, what are the different measures that they've taken, and what those rooms look like, and what kind of cleaning activities do they do to make sure that the rooms between patients are clean. So do look at this diagram, do read through that. All right. So we looked at all of the different aspects of enterprise architecture. We looked at data architecture, we looked at application architecture, technology infrastructure, business integration, services catalog, security, facilities. Now, uh, you know, there are commonalities between all of them. And the commonalities are all of them will have set of principles. So data architecture will have its own set of principles, standards, patterns, and guidelines, and exceptions, and technical debt. Each and every single aspect of enterprise architecture has these. These are common. One of the traits of an architect is that an architect is always on the lookout for what's common between things. How do I reuse? Those are two questions that we're constantly asking that you should start developing in your own. What's common, and what are the different patterns? What do you see there that's common between different things? So these are common between all the different pillars of enterprise architecture: principles, standards, patterns, guidelines. Principles. Let's see. Yeah, principles are usually something that are defined for individual, like facilities might have a set of principles, right? Um, Data architecture will have a set of principles. Application architecture will have certain set of principles. There are examples of principles in here. Security will have principles, and yada yada. So let's open one of them. And principles are published by several different organizations. The Open Group is one of the active ones. And you can scroll down and let's read an example principle. This speaks about the qualities of a principle. Let's look at that before we look at the example. So it's showing that a principle should be understandable, it should be robust, complete, consistent, and stable. And every time you write a principle, you have to make sure that you name the principle appropriately, and you should give a statement about that. And you have to rationalize, meaning you have to explain why this principle is a principle and why the organization should actually respect it. If the rationale is not strong enough, then people may not follow the principle. And what are the implications if you decide not to follow a particular principle? What are the implications, right? Are you going to be called into the principal's office? Are you going to be called into the CEO's office? Whatever the case might be, right? Or are you going to be called into whoever happens to be the head of, or whoever happens to be in charge of making sure this principle is implemented? All right. Let's take the Ohio. Usually governments and governing bodies will have principles published. So this is a publicly available state of Ohio published their information technology architecture principles, which is wonderful. Usually most organizations don't, but this organization did. So they have, the principles are actually classified into different sets. So let's pick application principles. First one, it says mobile first. When you're developing an application for a citizen or a business or a state employee, you must make it mobile first, meaning you need to make sure that it's mobile ready. You need to make sure that that application is available on a mobile platform. It could be a mobile application, or you need to make sure that the web application renders nicely on a mobile device, and so on and so forth. So this is a very, very good set of principles published by the state government Ohio here in US. So do read through that. I put a few more examples. There is a nice example by the UK, England, United Kingdom government. You please do read through those. And I found another one. Published by a university in Germany. That's another example here. Do read through that. Talking about Germany, quick digression. During my bachelor's degree, in my even final semester, we had the privilege at Vidyaniketan to learn Deutsch, and a few of my friends, we went through Deutsch. I took German classes, just an FYI. So these are some of the privileges that you get going to college. Standards. So once you have principles, okay, that's fine. Now standards. Standards are the ways that you implement principles. How do we, if something says, mobile first, okay, how do I do that? What is the standard way of doing something? So standards help you understand um, how principles are basically realized. How are things done? Principles are fine, but how do I do different things? So standards. This is a very good example of set of standards, and each and every single pillar that I showed you, data application, integration, security, all of them have their own individual standards. In a given organization, principals are usually owned by either a VP or a CIO or a CEO, or a CTO, depending upon which part of the technology. And then standards are usually owned by a director or a manager, or maybe an architect. Usually an architect scribes the standards, meaning he standardizes them. He provides the governance for standards, making sure the standards are met. An architect will review designs that are happening within a particular domain to make sure that the designs follow the standards. But usually standards are owned by the director level or VP level individuals, directors usually. And if a standard is broken, then the architect would take that particular project and say, hey, set of directors, there'll be a governing body usually, and they'll go to the governing body and say, this particular application that you asked, which is a patient-facing application, it's not mobile ready. If somebody launches this application on a mobile phone, it is not going to render the pages right. This application is not following our mobile first principles. And that application would be called into the principal's office, and either they would be given more funding to do it, or they might be disciplined for not doing or not following principles. That's standards, right? So next, patterns. We looked at some examples of patterns when we were going through our earlier session about healthcare capabilities. Patterns are different ways of doing the same, implementing the same standard, right? You could achieve mobile first using Angular, right? Or you could, implement one of the other flavors of JavaScript. You could be using jQuery. You could be using React. There are different ways of implementing the same mobile first, achieving the same mobile first principle and implementing the same standard, but you might have different patterns. In this case, I'm showing the patterns that are applicable to machine learning models. Now, you may have to change the way that you implement a machine learning model depending upon which pattern is applicable to that particular use case. If you have to expose your model, let's start middle here. If you have to expose your model as a service, then your design will be different. Your pattern might look a little different, right? Which is the COVID model we were talking about. You need to expose that as a service. A POP licensed PML model. So that might be a little different of an approach. So depending upon what is the design aspect, what is your solution, what's the kind of problem that you're solving, your pattern would be different. And there are multiple patterns to satisfy the same standard. And usually patterns are, so let's look at this. This is interesting. So there's guidelines, which are loosey-goosey, right? They're not strict, they're not patterns. They're guidelines that say, you can use React, or you can use Angular, you can use jQuery, or you can use one of them, but the end result is we need to make sure we meet the principles. Now, there are certain patterns that might become standard. For example, you might have a technology constraint or technology affiliation, maybe security reasons and such, might say, you know what, for this year, Angular seems pretty robust, so let's stick to Angular. And you might say Angular, but if you don't have resources that know Angular, if you're not able to implement Angular JavaScript, then you could use React or jQuery or some of the other flavors, but you have to get approval from the architects. Right, you could have a pattern and a guideline. Guideline basically says you could use the other ones, but you have to get an approval from an architect. All right. So we kind of threw both patterns and guidelines in the same breath. So I don't think we'll have to. Let's see. Let's pick one of these patterns and speak briefly so that you get to know a little bit. Yeah, all the way at the bottom is a good one. You could have a machine learning model that might need massively parallel processing, like CUDA cores on AWS. So you might be using convolutional neural network algorithms to do your model development and model implementation. So off the bat, your pattern is completely different. You're no longer using your x86 laptop to do model development. You have to be either a GPU based, like for example, NVIDIA DGX or NVIDIA Tesla. There's a NVIDIA Tesla GPU that's co-developed by NVIDIA and Tesla together. It's one of the best parallel compute GPUs out there in the world. And I happen to have one of them in our labs, and we're actually playing with them. It's NVIDIA Tesla T4. So you would need something like that to develop your model for image recognition. Right? If you are thinking about doing image recognition, I believe Rupesh mentioned you might be using some of the x86 algorithms, but if you wanted to do it real time, you'll have to use some sort of a GPU-based, parallel compute-based infrastructure to achieve the same level of recognition. Exceptions and technical debt. We talked about exceptions and technical debt briefly when I was talking about patterns and guidelines and what happens when somebody implemented a patient-facing application, but that patient-facing application is not mobile ready, meaning if you launch that website or web application within the browser on your phone, it doesn't render properly. It renders not so nice. The font is not correct. The aspect ratio of different buttons, the way that it looks, it's not friendly. So in those cases, you might have a need where you might say, you know what, we need to get this website out to the patients right away, and we promise to implement it to be mobile ready within 6 weeks of it going live. So instead of making it mobile ready when it goes live, you might ask for 6 weeks from the CIO that wrote the principle, right? They says any application that you build must be mobile first, must be mobile ready. But your web application is not. So you run up to you talk to your architect, and your architecture team, you're the governing body, right? Typically, the governing body for enterprise architecture is a team of architects. And your architecture team understands the gravity of the fact that this web application needs to be provided to the patients right now. And they propose an exception. They fill out a form typically and send it to the CIO. They go to the CIO's office, schedule a meeting with the CIO, and your application sponsor, whoever is asking you to build this application, is with you. They're sitting in the CIO's office, and the architecture team usually presents the complete design to the CIO and explains that this is what they basically help the CIO understand what the application does, and they maybe even give them a demo, give him or her a demo, and at the end of the demo, they'll say that this is how it's going to look on a mobile application, and they broke the principles and they did not implement it to be mobile friendly. The CIO might be maintaining a log or a record of all the exceptions that are happening within the organization. Usually the enterprise architecture team, this group of architects, are responsible to maintain that exception list, but it's governed by the CIO. So nothing goes into the list and out without CIO's approval. So the CIO would approve and say, okay, you have to deploy this web application to production because patients need this. However, I want you to come back and schedule a meeting with me in 6 weeks where I want to see a demo and I want you to implement this website version 2.0 where it's mobile friendly. And he would log that as an exception, which is proposed by the architecture team and the stakeholder, the sponsor of the project, and the CIO might give it a conditional approval to deploy, provided there is a version 2.0 that's coming up in 6 weeks to make it mobile friendly. Within 6 weeks, if all things go good, then that particular stakeholder will come back to the same CIO's office with the architecture team, present the application again, present the fact that it's and get their application taken off of the technical debt. So the CIO would provide the exception and add that particular application to a technical debt, right? Technical debt meaning this is very similar to debit and credit and debt and credit in the banking and finance world. So if you're not meeting principles, then you're creating technical debt for an organization. Most organizations that, for example, AWS or Google, will have very little or no technical debt in their portfolio. If an organization has a huge technical debt, meaning they're continuing to cut corners and find workarounds to things they shouldn't be, then that technical debt becomes humongous, and which is unfortunately true for many of the organizations. Many of the MNCs have huge technical debts, and the worst case is they don't have an enterprise architecture team. They don't even know that the technical debt exists, but they're suffering because of it. And that's one of the benefits of having an enterprise architect, or a set of architects in an organization, is to help you understand where do you stand as far as your maturity level goes from a organization standpoint, and how much of technical debt you've collected over a period of time. That's at the end of the day, who suffers? The end user. End users are probably launching a web application on an iPad or an iPhone or an Android tablet or an Android phone, or Microsoft Surface Pro or Windows tablet, Windows phone, and they're not rendering. The website is not rendering right for them. And guess what? Most hospitals, most end users these days are actually using mobile devices at the end of the day. Very few, especially doctors, are moving towards tablets. They're not, the laptops are quite bulky for them to be moving around in a hospital setting, so they're moving more towards mobile devices. Do read through the principles and standards and patterns and guidelines that I provided, and try to understand the workflow for the exceptions and technical debt. All right. With that, opening up the floor to questions. Any questions? Unfortunately, I kind of covered the contents fairly quick because we're at time at 9:30. So I do have a meeting coming up. Rupesh, I know you wanted to chat. We'll have to do that next week during next week's session. And please make sure that you have diagrams created and I'll do the document that you shared in the meantime, and I'll respond back to you with the questions you sent me in the WhatsApp. But any other questions, students? I do have to get to a work-related meeting. Any questions? Any questions from me? Did you hear what I said in the last 10 seconds? If not, I can repeat that. So Rupesh, I'll respond back to you after reviewing the document you shared, and I encourage that you create diagrams for the application that you're building so that we can have a more informed conversation, more than likely offline, and if needed, we'll share with the rest of the team. I'm thinking my work, rest of the students, when we get together for our next session.
Sure, sir. Kishore, sir, today's session was quite good, sir. The information, everything you have provided was really nice, much useful for the budding students.
Thank you, Ravi. Thank you. Appreciate it. I hope they review the content offline and they have little sparks of thoughts and ideas in their minds, and come back with healthy set of questions and
sure, sir. So behalf of the students, I just wanted a small request. Please do share the slides in the group, sir.
Yep. I will put the slides into the WhatsApp group and you'll get them.
Sure, sir. Thank you so much, sir. So,
thank you, everyone. Thank you for giving me this opportunity to share my thoughts with you.
Thank you, sir. Okay, students. So we will be meeting coming week on Wednesday, 6 p.m. Thank you so much. You can go.